My name is Balkar, and today our team will be presenting a comparative analysis for stability in bubble sort and insertion sort algorithm. Our group members are myself, Karan, and Prapmeet. From here on, Prapmeet will be taking over and talking about the research and analysis for stability between both the algorithms.
Hello, everyone, and welcome to my presentation on the research and analysis of the stability of bubble sort versus intersection sort. Today, we would dive into a comparison between these two sorting algorithms, focusing on their stability characteristics. Firstly, let's discuss the concept of stability in sorting algorithms. Stability means that the relative order of elements with equal values remains unchanged after sorting. This is crucial when dealing with data that has multiple fields, like sorting by last name, while keeping the order of people with the same first name. A stable sort ensures that this relative order is preserved. Let's move on the bubble sort. Bubble sort is a stable sorting algorithm because it only swaps adjacent elements when they are out of order. When two elements are equal, their relative order remains the same. For an example, consider the array 3, 3, 2, 1. After applying bubble sort, the 2, 3 stays in their original relative order, showing that bubble sort is indeed stable. Next, we'll look at the intersection sort, which is also a stable algorithm when an element is inserted into its correct position. It does not disturb the relative order of equal elements. As an example, consider the array 4332. Even after sorting, the 2, 3 remains their original relative order, demonstrating the stability of intersection sort. So, how do we measure the stability of a sorting algorithm? In this project, we approximately stability by calculating the percentage of elements pairs whose relative order does not change after sorting. Let's test this creative by creating arrays with 100 random elements, applying both bubble sort and intersection sort, and tracking how many pairs maintain their original relative order. Generating input arrays. To test the stability of these sorting algorithms, we will use different types of input arrays. These include random arranged arrays, arrays inputted by the user, and arrays that are already sorted. We would also measure how well the algorithms preserve the relative order of the pairs and track the time taken to perform the sort. This will give us a clearer comparison of their stability and performance. Now, coming on to the conclusion. In conclusion, both bubble sort and intersection sort are stable sorting algorithms. Though our test, we can measure and compare their stability quantitatively. Additionally, by timing the sorting process, we can also evaluate their performance in terms of speed. The next step will involve running these tests to gain further insights, which my fellow teammates would perform. Finally, I would like to acknowledge my sources, Greeks, for the comparison of sorting algorithms, and the Yash Chong research paper on the comparison of time complexity in different sorting algorithms.
So, moving on from here, I'll be continuing with the presentation. As we saw in the research and analysis, Prapmeet did talk about insertion sort and bubble sort. I'll be just going through it quickly. So insertion sort assumes that the first element is sorted, then it picks up the next element and compares it backward to the sorted elements. Once the element is placed in the correct position, it repeats the process. For the bubble sort, it's a repeatedly step process which compares the adjacent pairs and swaps them into their correct order if it's in the wrong order. And once it passes through the one bubble list, and it continues the process until it's sorted. Over here, I'll be talking about our code implementation overview. Our code is written in Python, and we use two Python libraries. First one is random to generate an array of 100 elements, and second one is time it. Time it is used to calculate the time taken by the algorithm to sort the array. So our structure of our program is sorting algorithms are placed in a function. Then we have a second function for the order preservation, which gives us the stability and percentage value for the algorithms. Then we have the user input prompt and a randomly generated array for testing. And then we have the sorting time and order preservation values that are recorded in the program and outputted. Here is our code. As you can see, we have three functions. The first function is the bubble sort algorithm, and the second function is the insertion sort algorithm. These two functions take one argument, which is the unsorted array, and the third one is our main function, which is the order preservation function. This function plays a crucial role in our analysis for sorting algorithm. So the function of it is to evaluate how well the sorting algorithm maintains the relative order of elements from original array to the sorted array. So this function takes two arguments, which is the unsorted array and the sorted array, and the goal is to count how many pairs of element retains their relative order after sorting, and then it calculates its percentage. So in this function, we initialize a variable called preserved pair, which is equal to 0. Then we have a nested loop, which compares the unsorted index of element I, which is less than, to the unsorted element of index j. And if that is equal to the sorted array, then it adds to the preserved pair variable. Once the counting is done, it returns the value in percentage for both the algorithms. Moving on from here, this is the second part of our program where we generate an array of size n, which is 100 elements, and the values are ranging between 0 to 1000. Then we have an if else statement for the user input, and once the user has been inputting their array, it goes through bubble sort algorithm and insertion sort algorithm. Once performed, it records the time as well as the pair order preservation percentage. Once done, that's the output from the user end of array. So this part of the code is pretty similar to the previous slide, except over here it's the randomly generated array of 100 elements. It's been taken through both the algorithms and then been processed and sorted, recorded in their times and also their stability percentage, and being output to the user. Here we have the data collection and outputs. So the recorded outputs include user input array, the randomly generated array, sorted as well as unsorted, sorting times recorded during execution of both the algorithms, and order preservation percentage for both the algorithms as well. Here is our code output. As you guys can see, we have the prompt for the user input where the user can input a set of elements. The set of elements are taken and displayed their original position and their sorted position from both the algorithms. The time taken for sorting process and the order preservation is presented respectively. Then we have the randomly generated array in its original form as well as in the sorted form from both the algorithms similar to the user input. Then we have the times recorded and the order percentage. If you guys want to compare both the outputs, you can pause the video and compare as well. In this slide, we'll be talking about the pair order preservation for bubble sort algorithm. As you can see, we have performed three different tests on a random array of 100 elements. We have the times recorded and the order preservation value in terms of percentage, as well as the average calculated from the three tests. Here we have the test values performed on insertion sort, which gives us the time for the three tests and the order preservation for the three tests as well. Here I'll be doing comparative analysis of bubble sort and insertion sort. In terms of time taken to execute, bubble sort takes an average of 0.00313 seconds with an individual testing time ranging from 0.00113 to 0.00153 seconds, whereas insertion sort is significantly faster with the average time of 0.00041 seconds and the tests ranging between 0.00031 seconds to 0.00044 seconds. As we can see, even though there is a time difference between bubble sort and insertion sort, the stability which has been executed remains identical for both the algorithm with an average of 51.95% across all the three tests. From here, we learn that bubble sort and insertion sort preserve their relative order equally for each element of their array, and it's just that insertion sort is way efficient compared to bubble sort in terms of sorting. So over here I'll be talking about the learning experience we had during the development process for the assignment. So for the language of choice, we initially started with Java as it was familiar to me and Karan. Later on, we plan to switch on to Python just to challenge our team a little bit and experiment with Python. So we implemented the algorithms in Python and Java as well, where we took out the times and percentage orders. But later on, we moved it to the Python for the assignment. The experience was great to learn about Python and experiment with it. We discovered that the code written in Java has better performance in terms of time execution compared to Python during our test. Later on, I'll be displaying it in the video. In this slide, we'll be taking a look at two different configurations and comparing their results. So on the left, we have current system configuration, and on the right, it has my system configuration. So for current system configuration, we have the CPU, which is Core i7 12th generation, RAM, which is 32 GB, DDR5 higher frequency, operating system, which is also latest Windows 11 Pro, and then we have the GPU and the storage. For my system configuration, we have the CPU as i5 11th generation, which is a previous generation. Then we have RAM, which is 16 GB and with less frequency and older generation as well. Operating system, I prefer Windows 10, so we have the Windows 10 version home. And then we have GPU and storage. The GPU and storage won't have a major impact but do a little bit. So we do have the results as well for the bubble sort and insertion sort algorithms performed on the same array, and it's just a different hardware at this time. So as you can see, the performance for current system is better than my system, even though it's just a bit half, I would say close to half, and but it still performs really better with different time recorded, but the stability is same for both the systems. Here I'll be talking about the tools used in the development and documentation process. So for coding, we used Microsoft's Visual Studio Code. It's a great editor, provides extensive plugins, and it has great debugging feature. We used both for Java and Python program. Initially, as we started with Java, I was using Intel IJ for coding in Java. It's a really good development environment. It has separate libraries, which gives us a great control over the programming process. And once we switched, I started with PyCharm, as I initially also been using PyCharm for Python. And for creating the presentation and documents we needed for the assignment, we used Google Suite. We used Google Slides for creating the presentation and Google Docs for creating the final report for the project. This helped us great in terms of collaborating and working real time with our team members. It is a really great tool for editing as well as working in collaboration with your team. And we use the PDF for exporting the project. Here is the work log and the tracking for the project. We used Google Sheets for dividing and tracking our workflow. We did have the time module for the date and having separated different tasks into different group members. As you can see, we have the research and analysis done by PropMeet. Then we have coding and development of algorithms with debugging done by me and Karan. Then we have written the final report with gathering testing information. Proofreading was done by PropMeet. So here is the final reflections and key takeaways of the project. This assignment has provided us valuable insight in terms of comparative analysis of bubble sort and insertion sort, which has helped us to understand not only the balance stability between both the algorithms but also the differences in speed execution in terms of sorting as well. The collaborative journey for this assignment was great. We had all the team members contributing their own part. Also, with the tools we used for collaborating and working together has helped us to overcome any technical issues. Thank you for watching our presentation and feel free to post the questions in the discussion forum and also with the feedback. We will love to answer those.